Welcome, everyone, to our AI Flash presentation. We're going to be starting up in just a moment. I have information up here on the screen about our AI days coming up March 5th and 6th. So if you have additional questions, if you want to learn more about AI, be sure to pre-register for our AI days. And also mention that we have, if you're here on the Vanderbilt campus, we have our AI Fridays every Friday, 10 to 12, here at the Data Science Institute at 1400 18th Avenue South, formerly known as the Sony Building. You're welcome to come by with questions about your AI projects. Can be large questions, can be questions about programming. You're welcome to come by. So let's go and get started. So I'm Jesse Spencer-Smith, and I'm Chief Data Scientist and Interim Director of the Data Science Institute at Vanderbilt University. I'm also Professor of the practice of Computer Science in the Department of Computer Science, currently in the School of Engineering, but beginning in just a few short months as part of our brand new College of Connected Computing, which is going to be the first new college at Vanderbilt in over 40 years. So today we're going to be talking about some fascinating advancements that were pretty fast breaking over the last week. And in particular, we're going to be talking about some advancements that were announced just on Friday. But first, we have to understand a little bit about some recent advancements in AI. Not everybody might have had an opportunity to interact with. So, in the past month, a little bit over a month, we've had on December 5th, the availability of GPT-4-Level model. So O1 is a special type of a large language model, which has reasoning capabilities. And the way to think about it is this. Generative AI models, when you use them, when you prompt them and ask for a response, immediately begin responding. And it's important to remember that as they respond, that's compute. So for every word token, actually, that they produce, that is additional compute, consideration of what they're going to be presenting to you. This is not unlike a person, and you might have done this at some point in life, you probably have, where when you've been asked a question, you begin answering immediately. You don't wait until if you know the answer, exactly what you're going to say. You just start talking. And you're going to probably land on the answer. You'll probably be able to get there, but you're answering before you know exactly where you're going. Well, that's been every large language model up until the release of GPT-4-Level. Let me put every commercially available, broadly available model acted that way. With O1 model from OpenAI had the fascinating ability to think before it actually presented words to you. So thinking before it speaks. In actuality, what it's doing, it's producing tokens, words behind the scenes, and it's been trained to actually think deeply about something before producing an answer. This gave it the ability to think very deeply before producing responses, make plans, and actually greatly improved its score on programming, reasoning benchmarks, math benchmarks. All the benchmarks seem to benefit from this ability to generate tokens, to think before actually beginning the actual answer. So much so that for most of the benchmarks, GPT-4-Level just shot to the top and actually advanced on what are the currently generally accepted hallmarks of artificial general intelligence. So that was on December 5th. That became broadly available. On December 20th, O3 was released. They skipped over O2 because of copyright reasons, so they went to O3. O3 significantly improved on this, went even further. The funny thing is, it appears that maybe O3 was simply doing more thinking before it responded. So more structured thinking before it responded. Nothing brand new necessarily, just more of the thinking before it responded. Well, this is wonderful. This is near PhD level, and in some areas, PhD level reasoning that is now available to you in a large language model. So we're really beginning to see the promise of AI now. But here's the rub. Well, actually, before we get into the negatives of that, let's go and try it out. So I actually want to come up with an example of of an interesting problem to give you all. But I haven't really had time to do that yet. So what I'm going to do is I have ChatGPT o1 right here. I'm going to say I am currently presenting to a group of people about uh, reason about LLMs that can reason. Give me a jaw-dropping example of complex reasoning for an AI to do in front of them. Now I'm going to hit enter. I'm going to notice something. It's not responding. It's thinking. Let's go and click on that. And we can see a little bit of what's going on behind the scenes. It's telling me a little bit about what it's doing, proposing intricate scenarios, analyzing scenarios. I'm digging into scenarios that require reading, summarizing, and analyzing text. I'm weighing the options. So this model has been trained to explore broadly and then to narrow down and then to evaluate, to do all this before responding. So now it's responded. Below is an example of a short murder mystery or whodunit logic puzzle. So notice here, so it's actually created a logic puzzle for me. And so not bad. Your task, identify who is guilty. What makes this a great demonstration? You'll notice that the points were already previously raised here, but now it's pulled together for us to be able to use. It's clearly verifiable, shows off chain of thought. Okay, these are all good reasons, and here's the solution. So instead of being chatty and giving me part of an idea and me having then to push it further, it did deep consideration, then provided me with a much more complete answer. So it's not just how to present. Oh, and this is how I'm supposed to present it. I'm supposed to give it to you. Then I'm going to ask for your guesses, and then I'm going to have the LLM solve it. Well, actually, I'm not. I'm just going to show you what's happening behind the scenes. So you'll notice that this was sort of the full solution. So now think about other problems that require deep thinking that you might want to do. We've used this to actually solve problems of programming. It's great for programming, scientific problems. So this is a broad range of problems where the model can consider and provide much more meaningful and well thought out answers before it does anything. But there's a problem. Anything that you give to OpenAI, you might be able to, you can pay extra and so it won't train on your data, but you're still sending it off to them. Even if you have an agreement where you keep data within an enclave, you've got to have that data, you've got to have that agreement in place before you can send data. And the fact is that this is expensive for OpenAI to do. I currently pay for the service at $200 a month, so I have unlimited use of o1 because it's that valuable to me. But it's $200 a month. And also, I don't have a lot of control over how it's thinking. I can't train o1 to work specifically on my areas of interest. I'm depending on it already having been trained in some way on what I want it to solve. Or I have to give it within context everything it needs to reason. So I can't customize it. And you know what? The advancements are only being made by industry, only by OpenAI. We don't know exactly what's going on there. And as a computer scientist, as a data scientist, as someone who does research in AI, as a former cognitive psychologist, I want to know. I want to understand. And are they taking full advantage? It's can be a troubling thing that these are closed source models and we can't modify them. We don't know what's going on. So remember, the last date that we had was December 20th when we had the release of O3. December 26th, a company called DeepSeek released a model that was the equivalent of O1, at least in terms of broadly being able to solve of GPT-4o. Let me put it that way. GPT-4o, not advanced reasoning, but the general capabilities of GPT-4, it seemed to match on the benchmark. So it's a huge achievement to match one of the leading frontier models by a company that releases only open source models. So this model was open source. They don't release all the training data that they used, but the model itself is open source. If you have a big enough compute center, you can run it on your own. It was a huge advance. Then January 20th, that's this Monday, DeepSeek also released R1. So R1 was based on V3, but added the ability to reason, much like O1. So now we have an open source model which can do reasoning, and we can actually begin to inspect how the model works. But you know what? It's still, we don't know all the training data that was used. Still is a very large model. In addition to releasing the R1 model, they also provided trained small models. So here's the thing. R1 is an excellent model at doing reasoning, and so it can generate as many examples as you want of excellent reasoning. So what they did was they tried out training Llama 3.3 and also another model called Qwen to see if by giving it significant training on thinking tasks, if it could develop the ability to reason. And it worked. And so what they did was they provide and released open source models that had been specifically trained. In particular, they released the Llama 3.3 model, 8 billion parameter, and the Llama 3.3, 70 billion parameter models, especially trained now to do additional thinking before responding, thereby greatly increasing their scores on a number of different benchmarks. And did the same thing with Qwen models. Probably the best model of the lot being the Qwen 32 billion parameter model that's providing, really excellent. These scores in these small models, which are small enough to run on your laptop, depending on how big of a laptop you have, but can run on your laptop, have scores that are very close to GPT-4o and certainly match the O1 mini model that was released. So now, in the span of a week, we have models that can do advanced reasoning, have 128,000 token context, length context. That means you can put a significant amount of text in them for them to reason against on your laptop. So first of all, this means these are open source models. We can now begin to actually experiment and understand how this is working and see if we can improve it even further. But even better, if you want to have a private, cost-effective way of doing advanced reasoning with models in a way that could be customized, you now have the capability because these models are free. They're open source. And we're going to take a look right now at something called LM Studio. So LM Studio is something which is also downloadable. I'm trying to remember if this is open source, maybe Umang, if you can, Umang or Sharo. Umang Chowdhury, Senior Data Scientist, Sharo Bell, Senior Data Scientist, Director of the Data Science Minor Program on here with us as well. Maybe you can put it in chat if you know that it's open source. So this is something that you can actually install on your computer to run these models. And let's go ahead and do that. As a matter of fact, let's do a couple of different things. One, I'm going to show you the model first. We're going to interact with it. Then we're going to give OpenAI O1 model. We're going to ask it to come up with another puzzle for us. And we're going to see if these small models, which are running on my local laptop, can solve these tough problems. And then I'm going to open up the floor and take questions and suggestions from you all, and maybe we'll try out some of those things as well. So let's go ahead and go to the LM model. So I'm going to go ahead to a brand new. So this is LM Studio. And here we're seeing a bunch of the advanced controls, and we can close out some of these advanced controls because we don't necessarily need to be seeing them. So we're going to clear those out. This is the history of all the chats that I've had before. And I'm going to go ahead and I'm going to upload the DeepSeek R1 distilled Qwen 32 billion parameter model. All right, I'm going to load the model, and I'm going to want you to look at the RAM down here. So you're going to see it's kind of a big model. It's taking up, okay, it's loaded up now. It's taking about 20 gigabytes of RAM. So I have a lot of RAM on my laptop, but this is the model that actually matches GPT-01 mini and matches GPT-01 in just a few of the one of the benchmarks. But to be clear, is running on my laptop. I'm not running on OpenAI servers. So I'm going to just say, you know, we're going to see how this works. Give me a cool example of a tough reasoning problem to showcase in a presentation about AI models reasoning. So a couple of things here. One, 32 billion parameters is a lot less than the huge number of parameters that O1 has. And so what you give up here is world knowledge. Everything that they may have been trained on the same number of items. I mean, these models were trained on 15 trillion different tokens. Maybe 10 trillion words or so spread out across many different documents. But it doesn't retain that much because it only has 32 billion parameters for its ability to store and its feed forward networks, all this. So it's very limited, more limited in the knowledge. Still has good world knowledge, multilingual, but not going to know as much detail as O1. But let's see what it can do. So notice its thinking. We're going to click on that, and now we're revealing its thinking. So notice it's not dissimilar from O1. Okay, so I need to figure out how to solve this logic puzzle where there's an island with knights. Okay, so it's jumping in. Here I've got to see if I can get to back up a little bit. So it's already creating a puzzle for me. Notice that it's still thinking and it's going through and it says, wait, that seems to be conflicting. So it's come up with a puzzle, found a problem. So it's backtracking. So the model here has been trained to think before it responds and also trained on how to think. Check your answers, double check, broaden the search, go deeper, validate, check your answers. So that's what the model is doing in the background. You'll notice it's not, it's not terrifically slow. I do have a fully kitted out Mac M4 Max with full memory in it. And I'm putting it through its paces right now. It's using up a fair amount of the compute. But let's go and take a look at a pre-prepared example, because I know this is going to take it about another minute or so to work through all of this. So I had previously asked for a good example from O1. So I said, help me come up with a task to give an LLM to showcase its reasoning ability. Oh, shouldn't have had the apostrophe there. This should be a complex problem that might not do well. It should be easy to assess whether it has done a good job. Here we can take a look at the thinking behind the scenes. It's crafted, and then it came up with what was really a complex sample logic problem. It had like people in different houses, pets and drinks, and it turned out to be really hard to solve, even for O1. So I went through this, asked it for the correct answer, and it was taking forever, and said, okay, look, come up with a new puzzle of this type, but start with the answer, then make up clues that are consistent with the answer. So it did this. It thought for about a minute, and it found a correct solution, and then spent a lot of time coming up with the puzzle, which I again thought was too complex. And so I asked for, let's make it simpler. Do just the person and the color of the house. Start with an answer, develop the clues. So it thought for 50 seconds, 52 seconds. This is the puzzle that it came up with. Good puzzle, simpler, and puzzle instructions gave me the reason why it was good. And here is a valid, here is the valid solution. And here's, it's interesting. It says, the answer that you get is guaranteed to be the only solution. There's only one solution to this puzzle. That was the whole deal with this. It has one answer. All right, so I tried this in LM Studio. First, what I did was I gave it to the, this is still thinking, I gave it to the unmodified Llama 8 model. So let's revisit here. The Llama 8 billion parameter model, the base model, chat model, it'll understand you, it'll answer your questions, but it hasn't been specially trained yet to think. It begins to answer immediately. So let's see what happens. I say, this is a puzzle. There are 5 friends, Alice, Bob, Charlotte, Dan, and Emily. Then it gives you all the information. And then I ask, please show me your step-by-step reasoning or a concise explanation of how you write out the answer. List the final arrangement for each person, specify the house color, the pet, and the profession. Oh, actually, that's kind of messed up, but it's, give me the answer. So to solve the puzzle, it goes through, immediately begins responding. It's done in just a few seconds, which is really impressive. It does try to do some reasoning, and it comes with an answer. And it's not right. So let's see if we can let's see what happens when we give the same task to now the DeepSeek trained 8 billion parameter model, still the Llama model, but it's had additional training on how to think. We give it the same prompt, all right? And now it's thinking. And it thought for a solid 2 minutes and 33 seconds. This is what it looked like. So first, let's list the clues. All right, let's get started. I'm going to make I'm going to try out the possible placements. So it's going through, trying the possible placements. It's coming with solutions that aren't working, so it's backtracking and reworking. It does a lot of this. So here's the interesting thing. It runs into a problem. So it gets here, and it says, let's verify all the clues. So it verifies all the clues, make sure that everything works, but it has a problem because it's found 2 answers. O1 gave me clues and gave me a puzzle that was supposed to have only 1 answer. This 8 billion parameter model, which is much, much smaller, has solved the problem, and it's running across another problem saying, you know what? I didn't find 1 answer. I found 2 answers. So it spends about an additional minute going through trying to disprove it because it got told there was only 1 answer. So where does it end up? At the very end, it says, after checking, it says, all right, the answers are, hence, I think the answer has 2 possibilities. Either Alice red, Bob blue, Cindy green, Dan white, or Dan white, Alice red, Bob blue, Cindy green. That's okay. Both are valid. So then it answers, based on the provided answer, there are 2 possible solutions for who lives to each other. Here's the breakdown, solution 1 and solution 2. This was running on my laptop. It did take 2 minutes, entirely private, entirely secure, cost me nothing because it's electricity. So let's go and take this back. Inform O1 that it's made a mistake, and we'll just see what O1 has to say about all this. So I say, is this also a valid solution? This is the answer that I got from Llama 8 billion, the specially trained one. Net thought for about 14 seconds. It went through, confirmed everything, and it says, we're going to check it against your solution. Puzzle recap, your proposed solution 2, checking each. Indeed, it is satisfied. In conclusion, all 6 clues are met by your proposed solution 2. Why do we have two solutions? Because both your solution and the original intended solution satisfy every clue. So now it's discovered that it's made a mistake. This is an error in O1 that was discovered by Llama, 8 billion parameter model that was specially trained on problem solving. So there we have it. Now the field is open to solving complex problems with models that are open source, that you can go and you can inspect, and that you can provide additional training on. Remember how I said that the smaller models don't have as much world knowledge? Well, if you have specialty knowledge, this could be in your research area, this could be in your business, but if you want the model to have specialized understanding of your particular area, go ahead and do additional training of that model in your area. It's called fine tuning. You can do it. You can actually even do some of it on the small enough model. You can run on your laptop, or you can get a beefier and get the training done faster. Then you can try training the R1 DeepSeek improved model and see if you don't mess things up, because you can get things called catastrophic forgetting when you train a model a lot. So you can try training the already trained specialized thinking model, say Llama 8 billion parameter. If that doesn't work, all is not lost. You go back to the basic Llama 8 billion parameter model, train it on your stuff, and then do the additional training for reasoning. And that way you get to safeguard that reasoning training. But in both solutions, you now have a specialized, personalized model that you can run securely, safely, privately, trained on your data, and yet still maintains the powerful reasoning capabilities that up until Monday was only available on OpenAI's O1, and you can run it on your laptop. There are versions of this model that even can run on your phone. Again, you give up world knowledge. You might give up some reasoning if it's running on your phone, but still far, far, far more advanced than we had on Sunday. We have far, far more capable models that can run in many locations today than we did just a week ago. All right, I'm going to go ahead and pause here, take questions, and see if you want to run anything against, say, our running LM model here. We can pull whichever model up you want to. Go ahead, and I'm going to give you the ability to unmute yourself and ask your questions, or you can put it into chat. What questions or observations do you have?
I have a question.
Yes.
Thank you so much for the talk and organizing it so quickly. So, the question I had was that we also kind of want to stay up to date, right? Rely on the latest information. So, is this already capable of making sure, like doing a web search for you, or how do you make sure that it keeps you up to date?
That's a good question. So, first of all, to be absolutely up to date, you're going to want to put that information in the context, right? Because retraining the models does take time. We're talking like days, weeks. So if you're trying to keep up to date, it might be trying to get the most recent information and put in that context window. The lovely thing is that these models do have 128,000 tokens, right? So that's enough. When you augment a tool, when you augment a model with a tool like search, what it's doing is it takes your query, does a search, and then just puts that into context. But keep in mind, this is the Llama model, so it's kind of stock standard. Even with the additional training, it's still the same weights. There's a slight modification that you do to the model, but anywhere where the Llama model could go, this reasoning model could go. So if you already have a solution that does what's called RAG or does search for you, you can drop this in.
Yeah.
And in LM Studio, there is a way to build tools with that as well. So this particular implementation doesn't solve that, but you can absolutely use this in a solution that does, because this specially trained Llama model or Quen model is a drop-in replacement for any model that you have.
Okay, just to add to a little bit to that,
Mhm.
sometimes you don't know exactly what you're looking for. That's why you
Correct.
could ask it that, hey, I'm thinking of it as a student, what is the latest literature on this stuff? So you're trying to do like a web search. So I'm just thinking
Yeah.
from that perspective, because if I'm adding the latest content, sometimes I don't even know what's the latest, right? So that's kind of where I
So
was just.
you you wouldn't want to query this like Google, right? Because again, smaller models, so it's lost that kind of like a fuzzy JPEG, right? If you want to make a JPEG really small, it gets really blocky. That's the memory in these models, right? Once it gets really, really small. Now, that being said, there's AI augmented search. Google has this. Perplexity has a very compelling model where you can actually even use some advanced reasoning. I wouldn't be surprised if they start adopting some of these models because it's a lot cheaper to do that. But they do broad searches and then use the AI to actually synthesize, you make connections. And so that's a good way to search for recent information and use AI at the same time.
Oh, that's perfect. Thank you.
Absolutely. Dr. Ya.
Hello, thank you for the amazing demonstration and putting together these useful overviews. I have a kind of broader question about the chain of thought reasoning and I guess the category of explainable AI. One of the challenges we run into, especially in the medical space, is people's concern about the quote unquote black box nature of AI, not fully understanding how it arrives at its conclusions. But when it's able to more or less articulate what it's
Right?
doing with this kind of explainable thought process that you can follow and it makes logical sense, it
Yes.
seems to minimize that concern. However, there are cohorts of folks that say, well, even the explanations may not fully be grounded in what's going on behind the scenes. So I'm just curious what your perspective as a data scientist is about
Okay.
how believable, if that's the appropriate term, the explanation it gives are, or whether those are really are more just superficial derivations based on what it thinks we need to hear.
So the whole idea behind explainability is an interesting one, right? Because because as you know, Dr. Ya, I did work in data science in healthcare for a while, and that was always a big request. We want to have the models to be explainable. But when we did explain, that didn't help, right? Because we could explain, well, the beta weights came from, well, that didn't help. And so now we have something which is closer to human. And the interesting thing is that, yes, the reasoning which is being shown in this thinking is sort of is what the answers are being built from. That does only take you to a certain point because there's a lot of work happening underneath the covers of what's being weighted, what's being included, how is the thinking influencing what the final result is. But it is a breadcrumb and it is something that you can follow. And in the same way that you can ask someone to express how they arrived at a problem and to justify it, you can ask an AI to do that as well. And if you're not satisfied with that, then I wonder how much deeper you need to go. Do you go that deeper with people? So they explain how they solved a problem and what they're citing and how they're doing it. But in essence, in truth, you don't understand how they solved it either, right? So that black box comes in somewhere, no matter what or who is preparing it. I'm happy with the direction of this. And I'm happy that there's validation that goes on in the reasoning. Um, and I think that's taking a step towards, and I think that we need to actually to establish and understand what we mean by explainable and really what we want from explainable. What do we really want from it? Because I can tell you what folks don't want is an exegesis on on a learning model. They don't want that. Even though technically I'm answering their question of how the model got to the answer, it doesn't satisfy them. Does that answer your question? Or
Yes, it does. That was very explained well. Thank you so much.
so you believe me? I don't have to go into the incubation states of. Oh, thank goodness. Okay, good. Or
Thank
Beth,
you.
how are you? What question do you have?
Great. How are you, Jesse? And echoing everyone else, this is fabulous. Thank you so much for doing it and doing it so quickly. So, given the puzzle example that you started with, it seems obvious that Llama would be very effective at finding flaws in data that you provided to it, but it seems that it would struggle to help you solve problems that required data that you did not feed to it. Are both parts of that correct or no?
I'm a little bit unsure about that because it depends on what the data is. Because remember so that this implementation in this LM that I'm running right now has no tools, right? So
Right.
one thing that's a really handy thing to be able to do if you want to feed data to a model is you give it a Python instance, you give it a notebook, and you say, if you need to do some calculations, write some code to solve the problem, get the answer and bring that back into context, right? So that's how you handle analytical, because it can do some reasoning, but the at the very basic level, the representation of numbers in these LLMs is not optimal for doing math. So the models can do math, but it's hard. It's far better for it to call a calculator for it to do the math and to reason against that answer. So it depends on what you mean by data. If the data is numeric,
And I mean data broadly, not limiting it to numeric data.
okay, so broadly, like non-numeric, even numeric data is okay. Non-numeric, great. It can find patterns. It can reason against that. We've done a lot of work with creating synthetic representations of things like light, like a gravity wave data, for example, just to see if the model could learn that new representation, and it could. So it can reason against data very, very well. It's got to be in that context window. Everything has to fit in there. The data has to fit in there, your queries, its answers, it all has to fit in that context window. So if it doesn't, that's when you run into problems. But other than that, it's very good at reasoning about words or concepts or even artificial concepts that you construct.
Love it. Thank you. Perfect.
Absolutely. Michelle.
Hi, Jesse. Nice to see you. Thank you so much for this. This is awesome. I guess I have a question. So with everything that's like happening, like you're like, being able to use like LM Studio or Olama to be able to push on and then like test these examples out, why is there still like a push for like alternatives, like using like the liquid neural networks or like the SSMs? Like why are people still trying to do that if we're able to use these on your like personal devices?
Because while I'm happy with 128,000 tokens, right, I would love a million.
Yeah.
I really would, because when you do a million, now you're doing things like, especially with the multimodal models, that's like an hour of video, depending on your encoding scheme. That is many books. I love being able to load multiple papers and to load multiple backgrounds in order to reason and solve problems. That's the only way I'm able to do the things that I do right now. I would be shivering in the corner with all the things that I have to do, except I have AI, so I can burn through this if I can load up that context. But I do run into the problem of like, I wish I could put that book chapter. I wish I could put that book in there and reason against that. Then I could really solve some problems. So more context is better, because that's where everything happens. State space machines, the SSMs that you mentioned, are one way of reducing the computational cost of going for longer and longer and longer context. It's not essentially a different way for the transformer models to work, but it's a different way for the attention within the transformer models to work. That's great work to continue doing. The liquid computing, the liquid thinking, liquid approach that we're talking about, very different, and that has to do more with fast learning, because these models are trained using very expensive and effortful backpropagation. So that requires a lot of compute. It'd be lovely to have, and we don't do that. I don't have to consume 6,000 calories every time I learn something new.
Right.
So if we could have a model that could learn with a lower compute, that'd be great for the environment. You could learn online maybe, because everyone thinks models learn online, right? It's like, well, I taught it this. So like, oh, and the terrible thing is that companies will say you can train your model using RAG, store your documents and you train your model, which is wrong. It's misinformation. It's looking it up and it's putting it into the context, but it's not learning. So that's why it's worthwhile to approach those. But man, we have, as you point out, we have extremely powerful tools now. We should leverage them for all they're worth for the problems that we're trying to solve.
Yeah, cool. All right, thank you.
Absolutely. Alan.
Hey, thanks for doing this, Jesse. I'm always amazed at how on top of things you are. And your point that you couldn't do this without using an AI assistant, I think is actually very, it's not a minor point.
Yeah.
What's going to happen in a few years is if you don't know how to use this, you're not going to be able to keep up. The productivity of people is going to go through the roof if you know how to use one of these AIs, or all of them, or a bunch of them. So it's going to become necessary. And I try to help my students learn how to use it in the class, let them use it in their assignments if they cite it like an academic paper, But anyway, listen, when I heard about this, I went to the DeepSeek website because I thought maybe that's where you download it from. And I couldn't figure out how to do it, but I did read their privacy statement. And their privacy statement basically says, we're going to keep everything you do. So how can that
right?
be the case if you're, I mean, you say it's online, or I mean,
Yeah.
it's offline. They're
Right.
saying, no, it's online. We're actually recording your keystrokes. We're keeping your, I mean, it was alarming, honestly.
Yeah, so so DeepSeek has an app that you could download and use, but when you're using the app, you're running it against their model, which is running on their computers
I see.
in China,
Right.
right? And so that's why I very much like the idea of like, just give me the model and the weights. Because that's really all that they did was they shared the model weights for Llama 8 billion parameter, Llama 70 billion parameter, the Quinn model. And then what you do is you take those weights, load them onto your computer with the framework, and then you run. You're not making any calls out to them.
That's good. I understand the difference there. Which
Yeah.
of the llama and the other one was called what? Quinn? Or?
Quinn. Yeah, so the Quinn model, and here I'll go now. So the Quinn model, and it's loaded up right here. So this is Quinn is also another Chinese company. They just really have the the leading one of the leading open source models for math. Llama's not terribly far behind, but math and programming, Quinn is really good. Sharo, I know you've worked with the Quinn model. Would you agree that the Quinn model is the best open source programmer right now?
I mean, I would say my love for Quinn cannot be overstated. It's my favorite. I love it a lot for writing in particular because it has like a great tone and it says things really well. But yeah, those are a great suite of models. They did a great job.
Yeah.
So you'd recommend then downloading the Quinn model when I just installed this
The LM Studio?
Yeah, LM Studio, and it came up first of all with a tiny little model, and I was able to bypass that. And then it showed the Llama model and a Quinn model, and they said they recommended the Quinn. So I was in the process of downloading it. It's pretty big, so I mean,
Pretty big.
may have finished, but maybe not. But that also is going to run on my computer without going out to the cloud, right? And I can do it
Up until you run out of resources, right?
right.
So depending on how much memory you have, what kind of GPUs you have. If you have no GPUs, I think LM Studio can still run, but it's going to take forever. Which is
Right.
why you want to use the smallest possible model. And it'll be up to you to decide sort of what you want.
Okay, well, I'm going to try out the Quinn model
Great.
then at some point. Thank you for your
Absolutely.
time and answers. I appreciate it.
Absolutely. All right. Other questions or other observations? All right, then. I'd like to thank you all very much for your time and for joining us. I will stick around on here just for the next couple of minutes to take any last minute questions people have. But we will be making a recording this available on our YouTube. And so be on the lookout for that. As soon as we're ready, we'll upload that. And also, don't forget, let me go ahead and put one more plug in here for our AI days. So go ahead, you want to learn how these models really work. You want to learn how to actually train one of these models. This is going to be for you, so you can learn actually to come up with that extremely customized advanced reasoning model that you can run on your laptop or maybe even on your phone. All right. For those of you who've stuck around and were too shy to ask questions in front of everybody else, do you have any additional questions?
So I do. So hi, I'm John. I'm actually at MTSU. We got invited by Miranda to come and sit in on this.
I'm so glad.
Yeah. So Q3 versus Q4 models. Do you have any thoughts on those? Using those because you save a little bit of memory, but I'm not sure if the performance is as good. Or I mean, that's.
Yeah. I mean, so a couple of things. One thing was that DeepSeek tried training the earlier versions of Llama models, 3.1 models, and they didn't get very good performance. They got much better performance with 3.3. So sometimes even changes within the versions of the models might make a difference. That pre-training, my bet would be that pre-training is important for the models for them to be able to accept and be able to represent the training. Architectures differ as well.
Yeah.
When you get to the
Not
small,
the quantization of the models, so
Yeah.
so just, yeah, right.
So what you want to do is you want to do the additional training on as a rich a version of the model as possible, and then go down to the smaller. But with the smallest models, you can try both ways, right? What they did find was that uh, they were able to quantize, down and still get good performance. So that's fantastic news. But it's a combination of all those things. Maybe one model which works at full precision doesn't work quantized, and maybe and there can be other models which quantize nicely but don't take the reasoning training.
Yeah,
So
so I've been playing with the Q3 model as you've been talking, and I've been doing a little bit of stuff here. And I just asked it a simple question of how many golf balls can fit in a 747, and it is just spinning. It is, it's just
Yep.
going in circles, and for minutes. At home, it went for about 30 minutes before it just basically gave up on my low-end graphics card back there. But
Right.
yeah, so it's interesting to see. I'm just kind of curious how that's going to work out.
Well, that's why now one thing that they mentioned they did not do was that they did not do reinforcement. They did do an alignment on these. They did only the supervised fine tuning using the 600,000 examples of reasoning, 200,000 examples of non-reasoning, just to make sure there wasn't catastrophic forgetting of other ways of working. But they didn't do alignment. They didn't do reinforcement learning. And they
Yeah.
believe that there's a lot more, that there's still gas left in the tank if you
Right.
also do reinforcement learning. So, but that's the lovely thing about open source. Let's try it, right?
Yeah, totally. Yeah, absolutely. Yeah, it's fascinating. I mean, these models are really good, but again, I've like my just low end experience using the smaller models is that they're really not doing as well as I would have thought they would on what I think
Right.
is a relatively simple problem. But
I've been impressed by the Quinn models, and I was
yeah,
stunned by the reasoning capability of the Llama 8 and of the Quinn. Uh,
yeah, I'm using the Quinn 32 Q3 right now, and again, it's just kind of getting lost. It's
it could be, yeah, yeah.
yeah,
And you are using and you're using the R1 distilled version of it.
R1 distilled.
Yeah.
Yeah, oh, okay. I should let
Yeah,
other people ask questions, but thank you so much. I appreciate it. Great talk.
absolutely.
Thanks.
Absolutely. Thank you. Dr. Yeah.
Yes. What are your thoughts? I think it was a week or two ago. Everything's moving so fast. I think it was Berkeley that had the Sky T1 or something like that. I think they did fine tuning for 450. So what are your thoughts around that space and things going on in that area?
Let's see. Yeah, and yeah, things come fast and furious. Um, so I'm trying to remember. Can you give me some of the details so you can remind me of it? Because I'm trying to remember that now.
Yeah, basically, I think it came out right around when OpenAI had started to announce some of their pricing for some of the other models they had coming in through, and like the pro subscriptions, like $200 a month, etc. And
Right,
then
right,
Berkeley
yeah.
said that you can fine tune their open source model, get similar performance, but it was just $450.
Right, exactly, which I thought was really quite interesting. Um, but the thing is, I love saving money. Oh, that's right. Yeah. That's the Sky T1 32 billion preview details. I think that with the open source models, we're gonna find, because if you think about it, you have one company or like maybe four companies all racing, trying to solve problems in particular ways. If you have open source models, you're going to have many different ways to try to solve. Their solution is nice, but you're still sending data off. It'd be far better if you had it local, even better if it's open source. Best is open source plus all of your training data is open sourced as well. That's really, really open source. I think that's the that and smaller models is the answer to answering, all the questions of privacy, understanding where the model gets its background from, being able to fully specify what's happening. I think unless you have that, every answer, even if it's cheaper, is only a partial answer. That's my thought.
Really good points. Thank you.
Thank you. Max.
Yeah, I had some questions about approaching this for mobile devices. It's getting a lot easier for us just to install and run these models locally on a desktop or a laptop. But as we're training or customizing or trying to fine tune specific models that can run on or that could run on a mobile device, are there any projects out there that we would have access to in order to actually run them?
So actually, the Data Science Institute is actually exploring the running models on device, and we're exploring doing fine tuning of the models. Actually, we had on our whiteboard right over here a project to explore doing training of these models, and we were talking about reasoning as well with the models. And so when this came out, I was like, well, guess we don't have to do that project. It's that problem is solved. So that really the issue is defining the project around it and then seeing how well it can work. Because as was just being pointed out, sometimes the models just can't solve certain kinds of problems. So once you define your project and what you want to do, then you see if the small model is capable of doing it, whether it requires additional tuning. The reasoning, I think, really, the reasoning in the small models is really going to improve their overall capability. Across all different measures, not just ones having to do with reasoning. So I'm very much looking forward to exploring. We've just begun to explore what these smaller models look like. I'm looking forward to seeing smaller models that can be on device and seeing if they can take that additional training as well. Because if they can, it's going to same footprint, same memory footprint, extra compute, right? Because it has all that extra reasoning that happens before it answers, but a lot more bang for the buck in the same memory footprint.
Great, thank you.
Yeah, absolutely. All right. All right, great. Absolutely.
I do have one question for
Yes,
you.
Alan.
How did the things like DeepSeek actually modify an existing model? I mean, I've been playing around with Stable Diffusion, and they have these things called LoRa's that you can load in, and we'll is that the same idea?
Love our LoRa's. What DeepSeek did was not that. They did have to modify a little bit to introduce or to use an additional special character, a special token, thinking and thinking, because they need to be able to say, don't show this, handle this separately. You're operating, when you're thinking, you operate like this. You're talking to yourself, you follow these thought patterns in thinking, now you're responding as usual.
So is it parsing the token stream or something? I mean, how does it actually do this? Because the model's already trained, right?
Yep, same model. The only thing that's different is it's responding differently. But you know how you can align a model, and so an unaligned model that has no reinforcement learning at all may or may not be very chatty, right? It'll answer your questions.
Mhm.
It'll be blunt. It may not be helpful, right? You align the model through reinforcement learning, and it can respond better. Well, you can also do that through fine tuning as well. Respond in these ways. So that's what they did. They said, when presented with a problem that is of this type, recognizable as something where thinking will help, first produce the thinking token. Whenever you have that thinking token, then you act in the following way until the problem is sufficiently solved, and then you give the end thinking token. Now, after the end thinking token, you respond regularly. So it's
I
all,
see. So it sets up all the possibilities with the thinking token, and then
but only through training, right? No change in code. Only change in thinking, only change in training.
Fascinating.
All right.
Thank you.
Absolutely. Any final questions for folks? All right, then I think we will go ahead and close this up, and we will turn off the recording. Thank you all so much. Have fun playing.